Cooling season 2025 is weeks away. We began this year looking at some modern junk. That's just the way it needed to be because that project was time sensitive. Now we're going to take a 180 and look at some quality old equipment. And we have to look at this in the dark for a couple minutes because I was vacuuming just prior to this video and I plugged the vacuum into the wrong outlet and overloaded the circuit that the lights were on, so I have to wait for the lights to cool down for a few minutes before they will restrike. So with that being said, this is a Sharp air conditioner. This, I believe, is a 1990s unit. It is the Sharp, or the Dole, AF-802M6 air the conditioner. It is 8,300 BTU, 10 which is actually pretty reasonable. The day code is 92C. It's very possible that that's 1992, March of 1992. This looks to be about that old. It's in okay condition on the outside. It's pretty rough on the inside. The side panel here, the accordion thing is in good condition. I think we'll save that to use on another machine. It's of no use on this machine because the plastic piece that holds it out is missing, or I think it's actually busted. I can see bits of it right there. So we're just going to take this off and I'll add it to the pile of parts. Don't need this in my house because the windows are so small, so I'm not concerned about trying to repair this. I'll just put these screws back, or I'll just throw them on the floor. That's great. Oh, I'll put two of the screws back. The other one is on the floor. Nope, it's not going in nicely. We'll just, whatever. Okay, anyways. So that's that. Let's take a look at the back. Condenser's pretty rough. We got some serious decay over there. It looks like the whole, that thing that holds the coils is actually just gone. It's just continuing to crumble. You know, it actually is probably better for it to be gone because when this starts to rust and it gets sharp, it can vibrate up against the loops and then create little pinholes, which leads to a leak. So I guess in this case it's just as well. Pretty bad coil rot on the bottom. The coil is just gone on the bottom. That's fine, it can still run. It'll run just fine like that. As we've seen in many times, these things can have pretty much zero condensing surface left and still work just fine. We'll go through and straighten all this out, get this coil looking good again. It's a high efficiency coil. They're a bit of a pain to straighten out because it's not just a fin, it's a fin with a little cutout. And you can see it pretty good right in the center of the screen. It's not just a vertical fin, it's a fin with little cutouts that go off to the side, and so it's just a pain in the neck to straighten it out. Plus it's a very high number of fins per inch, but we'll get it. I've done plenty of these, not a problem. The logo is pretty much gone. This is the drain hole, I guess, but it didn't work. Well, it worked the way it was designed to, which is to hold, you know, a fair bit of water in there, which is why the coil is shot. And that's why we drill the hole and let all the water out. Do we have lights yet? We do. Okay. Let's take a look inside. It's surprisingly decent in certain parts, at least compared to the way the back is. I'm going to look up here, that's better. There's a fair bit of the paint left, and then I guess it's pretty rough back there still. Yeah, a lot of rust. The information's on the fan motor. It's the M. I'm not sure what brand that would be. 1 amp, so it's got to be a PSC motor. The fan has a lot of blades. Probably pretty quiet. This is made in Thailand. I was expecting it to be made in Japan. The compressor, probably not going to be able to tell. What is it? What does it say? I wonder if it's his Matsushita Electric Industrial Company. Where was this compressor made? In Japan. Okay, so the compressor is made in Japan. Alright, now that we have lights in here, nice metal halide, not stinking DEL. Put the camera back here. There we go. Now we can see it. It's very lightweight for an 8000. Oh, for heaven's sakes. Here we're sitting here peering through the stinking thing and it's a slide out. Okay, well that gets the derp award of the day. Now we can get a good look at it. Okay, now can I tell what the brand of it is? No, I still can't really tell. Let's see if I can zoom into it at all. Come on! Matsushita, okay. Very good compressor. Is the fan motor ball bearing? Yes, it is. Yeah, what a shame. This is why you gotta drill the drain hole. This would not have happened if this had a drain hole. What a joke. I think that every unit should have been slide out. It just makes it so much easier to clean and service. This is sliding in and out surprisingly easy, considering the amount of rust. The adjustable register. I think this is something to do with. This is that stupid little vent thing. Whatever the heck that's worth. It's pretty much nothing. Oh yeah, let's put air through a tiny little hole. That's really going to refresh the air in the room. What a dumb feature. Looks like this might have been at least partially cleaned at some point. The blower wheel's pretty clean. And the evaporator's pretty clean too. It looks like it was clean, but there's just so much rust flakes in the back. It's kind of odd. And this looks like it might have been straightened out at one point. Yeah, this was definitely... I don't think it was done with a coil comb though. But there was a pretty good attempt made without the correct tools to straighten this out. Here's our thermostat. It's kind of weird. Just a tiny little thing off to the side like that. Alright, well, let's turn this thing on and see it run. I'll be testing this myself for the first time. I was told it works and have no reason to believe it doesn't, but I don't know how it works. It does not have continuous run. That's clicking on just right around 8, and it's 71 degrees ambient. Alright, here we go. We're testing at 118.1 volts. Turn that off to begin. And here we go with the fan. Hear all the rust chips blowing around in the back. That feels about right for an 8000, assuming that's low fan. Seems to be medium. Yeah, very quiet, like I suspected. Both inside and out is pretty quiet. I have a lot of respect for Sharp equipment. I think Sharp made a really good air conditioner. That's very reasonable noise level. And the register can be angled up away from the evaporator like it should be. And we have two different directions that it can angle at. And it does angle pretty good. The fan is 0.65 the amps on low, 72 the watts with a power factor of 0.93. That's kind of low. Medium is 0.73 the amps, 82 the watts with a power factor of 0.95. And the high pool is, or it's just fan, 0.96 the amps, 107 the watts with a power factor of 0.95. So the capacitor might be a little drifted. I would have expected something like this to be at least 99. So it might be worth checking the cap at some point. It is over 30 years old, so the cap is definitely, well, assuming it's from 92. Was it 92, 2002, 2012? Yeah, it's over 30 years old, so the cap has done its time. Where's the compressor? Over here. I'll just move the camera. A little bit of a startup sound there on medium. A little bit on high, not much. A little bit on low. Alright, so I'm going to start the compressor now. From my experience, these Sharp units tend to be very chattery. So let's see what this sounds like. Yep, it's chattery. I just heard the gas clear out, so this is working with a good charge, I think. You can hear the gas in there now. Actually, I can hear the coils turn. They're getting real cold already. Wow, yeah, it's freezing cold already. I think that this evaporator coil is only one layer thick. Yeah, it is. This is only one layer thick, so it's going to get cold pretty fast, as we just saw. Get our temperature thing set up here. Really well prepared for this video. Got everything just set up perfectly. So according to the thermometer over there, the ambient temperature is 71. According to this, I was just holding it. The ambient temperature is 73.4. So we'll use 73 as our baseline test. 73 Fahrenheit, 23 Celsius. That compressor sounds like garbage. I wonder if we're still getting any reasonable airflow out of this condenser. Yeah, actually we are still getting pretty good airflow. It seems like just the very corners are screwed up. The middle seems okay. I do feel a lot of air escaping from the left side there, so we'll have to put some spray foam in there or something. This is making some very interesting refrigerant noises. I just noted this is ETL listed, not UL. It's kind of interesting. Very, very interesting refrigerant sounds. So we're up to about 6 amps of the allowed 7.7. 650 watts with a power factor of 0.93. Yeah, we got to check the cap on this. That seems a little bit low to me. Seems to be working without complaint, but that doesn't mean it's not a little bit drifted. And we're getting a good temperature out of it. We're down to 43 and seems to be still falling. Getting, wow, a lot of heat out the back now. I wonder how thick the condenser is. Probably just a 2-row. Oh yeah, that's cold. Down to 41 now, or 5 degrees. Celsius. Yeah, this is good stuff. I really feel like Sharp makes a I don't think they still do, but Sharp made a very, very good air conditioner in the 90s. Even in the 2000s, although I guess by the time we get to the 2000s, it was probably Electrolux making the stuff. So we'll go to medium. We might see a pretty good temperature rise because the coil's not very thick. high. The medium speed seems kind of weak. Another indicator to check the cap. That might just be the way it is, but it seems kind of slow to me. One of a few degrees, but nothing crazy. We're up to 6.62 the amps out of 7.7. And it's under very, very little load right now. Good heat out the back, pretty cold in the front. Definitely a very respectable delta. And the compressor sounds just fine now. Just had a few minutes of chattering to do at the beginning. Actually sounds pretty nice for a rotary. That's 6.87 the amps. See what it goes up to on low. You can hear the compressor just came under considerably more load. It's already up to 6.8 amps. When it's hot out, it's really important to run this type of unit on high because you need as much condensing cooling as possible. "42 degrees, that's really cold. Let's see if the coil's cold all the way through. I'm sure it is. Yep, it is. Not as cold on the top as the bottom is, but it's one layer thick, so that's kind of to be expected. Alright, this is working good. Down to 40 now.